Okay, let's look at one of the typical integration question, which you will get the gradient is given to you, gradient of the curve. Then after that, you probably need to find the equation of the curve. All right, typical. Okay, let's start with this one first because we have the gradient of the curve given in this particular expression. Okay, P and Q are constants, so the first part you're supposed to find for me P and Q. Okay, this one here, right, they said that the gradient of the normal at this particular point is -1. Got to be very careful because, right, gradient of the normal equals to -1 is not my dy dx. My dy dx, right, is always my gradient of my tangent from here. So how do I find the gradient of the tangent? I got to understand that the gradient of both the normal and tangent multiplied together is -1. So I'll take -1 divided by my gradient of my normal. So what we understand from here is dy dx is equals to 1. Okay, so this is my curve, this is my tangent, this is my normal. The normal is at this point here, right? Which is also lying on the tangent. So that means what we have here is that we just need to take the x coordinate. Okay, remember whenever you are doing a dy dx, right, you don't need the y coordinate. All right, you always need to sub in your x coordinate. You only need the y coordinate if you are finding coordinates of that particular point. Okay, so doing this part over here, dy dx is p plus q over x cubed. So that is 1 cube. The gradient is 1. Yay, I got my first equation out. So you see two unknowns, right? High chance, simultaneous equation. Okay, so the next one, we need one more equation, right? Now, gradient of the curve at this is this one here. What's the gradient at this particular point? Y equals to mx plus c. My gradient is 8. What am I doing? My gradient is 8. Okay, gradient is 8 at x equals to 2. So what we're going to do is gradient is 8. So p plus q over 2 cubed, that is 8, right, is equals to 8 from here. Make their denominator the same. This is my second equation. So judging from this, right, it's easier to make q the subject so that you sub lesser, right? So q is equals to 1 minus p. So 8p plus 1 minus p, 64. 7p is 63. So p is equals to 9. This is one of my answer. Got to find q first. Careful, okay? When I was a student, my 9, my q, my 2, my z, and my 5 and s all look the same. So just be careful, okay? Okay, so q will be 1 minus p, which is 1 minus 9, which gives me -8. Okay, settled. We got p and q. 4 marks, quite kind. All right, so they tried to trick you by giving you gradient of normal instead of gradient of tangent, okay? Okay, next one. So using the value of p and q, okay, let me just write down first. So my dy dx is p is 9. So 9 minus 8 over x cubed, right? Okay, very hard to integrate and differentiate. So 9 minus 8 x power -3. So in order to find y, I got to integrate my dy dx with respect to x. Did I say integrate or integrate, right? Okay, so integrate this thing here. So when I integrate this, integrate 9 gives me 9x. This one here, integrate add 1 to the power, divide by new power plus c. Don't forget. All right, so simplify further. 9x plus 4 over x squared plus c. Just use any coordinate that lies on the curve. So for me, I will use 1 and 4. 2 and 10 also lies in. You choose which one you want to put. Same method. Just one is a little bit more troublesome than the other lah. Okay, so y is 4. 9 times 1, 4 times... Oh, that's nice. See, I chose the right one. But I never got 0 and 1 is the best case scenario. Plus c. Okay, so what I'm going to do is 4 minus 9 minus 4. Ta-da! So my c equals to -9. Some of y'all, right, y'all did calculation error, I can tell, because eventually y'all got like 1. Instead of minus, I think y'all plus. So that's why y'all got 1. So just be careful lah. Okay, so anyway, my y is 9x. 4 over x squared minus 9. Beautiful answer. Right, so typical algebra, straightforward. 2024 TYS also had very similar questions. So this one considered quite easy, okay? So just make sure you take note. Okay, the bottom part over here, this is the one that most of us are struggling. So I want us to take note of two things, okay? They will ask you to show two things. They will ask you to show that y is increasing, and they will also ask you to show that, like in this case, right, gradient is increasing. So what I want you all to do, always be very careful the moment you see the word gradient, okay? Because when y is increasing, right, you differentiate your y and you show me that it is more than 0. Am I right? But when they say gradient is increasing, you have to differentiate your gradient, which ends up as d2y dx squared. And then you want to show me that it's more than 0. Can you all see the difference here? Okay, so this one here is gradient increases. So you got to differentiate the gradient again. All right. Okay, so what's my gradient? My gradient is over here, right? So I'm going to find my d2y dx squared. My d2y dx squared will be differentiate 9, nothing I can do, bring down x power negative 4. So it's 24 over x power 4. Okay, how do you show me that this is a showing question, not find the range. So you got to show me that this is positive. Okay, so remember when you have numerators and denominators, peel it open. Same for products as well. Okay, so for sure, 24 is 0, more than 0, right? So 24, put a small plus here, positive already. You know that x power even numbers will surely be more than equals to 0, right? But I don't want more than equal, okay? So what I want you to see is that this one merely said, right, y increases. There's no criteria in the question, okay? So if what x increases, what am I talking about? Okay, if x, right, is 0, right, then x power 4 will also be 0. Correct? But we don't want that. We want it to be more than 0, right? So you ask yourself, is it possible? Look at my equation, okay? They are saying that this is a curve. If this is a curve, if I put in 0, 0, this whole thing will be 0, right? I'll get y equals minus 9, which my graph will look like this. It's not a curve. So what happens here is that, right, you have to understand that this one here, for real values of x, and in this case, we should automatically reject x equals to 0 already, because cannot happen. If x is equal to 0, we're not going to have a curve, right? So this since it's like that, right? So you confirm plus chop, whether it's negative or positive, right? You power 4, right? See, negative 1 power 4 is also positive, right? So surely more than 0. So what we understand is this 24 over x power 4 is going to be more than 0. So our understanding is our second derivative is more than 0. So therefore, my gradient is increasing as x increases. Can you all see the understanding here? Okay. So remember when we are doing what you call it function y increasing, you differentiate y. So that's dy dx more than 0. But now you're doing gradient, right? You're going to differentiate the gradient, which is d2y dx squared more than 0. Okay? Okay, only the last part need to be extra careful, okay? The first part and second part, I think you all did quite well. Keep it up.